Hey everyone, this is the Radko Tutor here explaining. In this video, we are going to look at differential equations, and the type of differential equations that we are looking at today is separation of variables. So, we mentioned earlier on in our previous videos that differential equations are those equations that contain dy dx in them. So equations that contain dy dx in them are called differential equations. So if you look at this equation I've written, you are going to realize that it is having dy dx in it, and therefore this becomes a what? A separation of variables because of this dy dx which is in it, like that. All right, now if that is the case, then now we need to know the form of questions that come under separation of variables. So for you to know that this is a separation of variables, it means you are supposed to be given a differential where you have a part for function of x and a part for the function of y. So you can be given, so we can say that e.g. you can be given functions of this format where you have dy over dx is equal to f of x comma y. Okay, so what I mean is here is that you'll be given a differential equation where you have a function of x as well as the function of y. Example given, we can say we have dy over dx is equal to 2x over 3y. Have you seen how this question is? You are given this part on top here, which is the function of x, and the part which is down here, which is the function of y. So by doing so, that means you have the differential equation which is having both the function of x and the function of y. That means for you to solve this type of differential equation, you are only supposed to use the separation of variables. Okay, without using the separation of variables, it becomes very hard for you to solve this particular differential equation. Now, let me continue giving you examples. So if we have that as our first example, number 2, we can have dy over dx is equal to x plus 3 over x minus y. So you can also see that here you have the function of x and the function of y. That means that this is a separation of variables because it has two different functions, and then there is this dy dx here. So that's how you know that this is a separation of variables. Now, after knowing how the separation of variables are set, now we need to know how to solve them. After you identify that this question is supposed to be solved by separation of variables, now you need to know how they are solved. All right, so let's look at examples and see how we can solve these separation of variables. So we are going to look at examples. So examples, we are going to say solve the following differential equations. Solve the following differential equations by the method of separation of variables. Sometimes they will not even tell you that this is separation of variables. They will just say solve this differential equation. So you're supposed to know by yourself how the equation is written, or how the form comes for the separation of variables. Now in this case, we have our first question, which happens to be a. We are saying dy over dx is equal to 2x over y plus 1. Now, how can you solve this differential equation? So for you to solve this differential equation, when it is separation of variables, what you're supposed to do is, you know that you have the function of x and the function of y. So whenever you're solving using the method of separation of variables, meaning that they want you to attach the function of the x the function of x to the x and the function of y to the y. That's what they want you to do. So attach this function to this and that to that. How can you do that? We are going to start by rewriting solutions. We are going to start by writing the question, which is dy dx is equal to 2x over y plus 1. So by doing so, we are going to do this. We want to attach the function of x to the x. So what you can start by doing there is simply very simple. You can start by multiplying this side by dx. You also multiply this side by dx, so that this dx and that dx will go, and then you end up having dy is equal to, you have the 2x over y plus 1 dx, like that. Now we are saying that we want to attach the function of x to dx. This is already what we've done. But also we want to attach the function of y to dy. So what can we do? We remove this 1 plus y. We need to take it to this side of the equation in order for us to only remain with the 2x dx that side. So by doing so, we are going to also multiply this equation throughout by y plus 1. This side also we multiply by y plus 1. So that this y plus 1 and the y plus 1 there will go. Then we end up having, this side we are going to have y plus 1, which is this one here. And then dy, so we write the dy is equal to this side also we have 2x dx. Now after you've separated the variables, what you need to do is to integrate both sides of the equation. So you need to integrate both sides of the equation. You need to integrate this side, you also integrate that side. So integrating this side, y plus 1, you are going to have y squared over 2 plus integrating 1 with respect to y, the answer is y. Then is equal to, you come here, you integrate 2x with respect to x, you're going to have 2x squared over 2, and then you say plus c, which is the constant of integration. So you can cancel the 2 and the 2, then we end up having y squared over 2 plus y is equal to x squared plus c. So this becomes our final answer if we are to integrate this particular question at this point here. Remember, we are solving the differential equation, which is separation of variables, and we need to start by separating the variables before you integrate. Alright, so that is how you can solve this differential equation by separation of variables. So you need to start by separating the variables. That's when you can now go into calculations. Let's proceed. Let's go to question number 2. So question number 2, which is B in this case, so we can call this as B since we are using A on top. Now we are going to have, let's have dy over dx is equal to 1 plus x times 1 plus y, like that. So again, when you look at this question, you are going to realize that you have two parts. You have the function of x and the function of y. Then there is dy dx. So first it qualifies to be a differential equation, and then it is a separation of variables because we have two functions, the function of x and the function of y. So that means we should start by separating the variables before we integrate. So we write our question, which is dy over dx is equal to 1 plus x times 1 plus y. So what do we do? Always start by multiplying by the x both sides of the equation. That means this one and that one will go, and then our dy will be equal to 1 plus x times 1 plus y dx. So from there, what we are going to do then is to also remove the part for 1 plus y, which is still this side. So we need to remove this part because we are saying that we should only have the part for x attached to the x. So since we've seen that we still have the function of y, we need to remove it. How can we remove it? We are going to multiply this side of the equation by 1 over 1 plus y. We also multiply this side by 1 over 1 plus y. So that this and that goes. Then we end up having 1 over 1 plus y dy is equal to this side. We are remaining with only the 1 plus x and dx. So by doing so, you can now integrate because you fully separated the variables. So you are going to integrate this side of the equation. You also integrate this side of the equation. So integrating this side of the equation, 1 over 1 plus y is natural log of 1 plus y. Then is equal to, integrating 1 plus x is x plus x squared over 2. And then you say plus c. So basically that's how you get to solve these questions coming from separation of variables. Let's do more examples. Number 3, let's say we have, so this is going to be c. Let's say we have x dy over dx is equal to y plus xy. So in this case, what you're going to do is, we have two functions. you have the function of x and the function of y. But before you even solve this question, you can start by, since you've seen that to the right hand side of the equation you have y common to both sides, you can first factor that y out so that you have 1 plus x inside like that. Now, after I've done this, what you can simply do is to now separate the variables. So I'm saying whenever you separate the variables, start always by multiplying this side by the x, this side also by the x. That means this and that will go. Our x dy will be equal to y open 1 plus x dx. So after you've done that, you need to also remove this part for y, this side of the equation, so that it is taken to the part of the y. So by doing so, you need to multiply this side of the equation by 1 over y. You also multiply this side by 1 over y. That means the y and the y will disappear. Then we are going to remain with 1 over y x dx, dy is equal to this side we have 1 plus x, then the x, like that. Now, here, what have we really separated the variables? The answer is no. Why? Because we are still able to see that we have this x which is found to the dy. So we need to remove this x, taking it this side of the equation. So by doing so, we can multiply again this side of the equation by 1 over x. We also multiply this side by 1 over x. So by doing so, we are going to realize that the x and the x will go. Then we end up having 1 over y dy is equal to 1 plus x. 1 plus x times this 1 over x, which is going to be, so let me just multiply there. So we are multiplying this 1 over x to 1 plus x, which is going to be 1 over x times 1 is 1 over x, plus 1 over x times x. That x and that x will go, you remain with a 1, and then we say dx. Then from there, you can now integrate, because here we've now fully separated the variables. So by integrating, you integrate this side, you also integrate that side. Integrating this side, we are integrating with respect to y, so it becomes natural log of y is equal to integrating 1 over x is natural log of x, then plus integrating 1 with respect to x is x, then plus c. So that becomes your final answer if you have to solve this differential equation here. So that's how you should be able to do it in that order. We need to do more examples, so we go to question D. So question D, what you're going to do is we are going to have this as our example. All right, so we can have dy over dx is equal to 1 plus y over 2 plus x. So how can you solve this type of differential equation? By the way, start by identifying the type of differential equation, and we are saying this is a separation of variables. So if it is a separation of variables, meaning that you can start by attaching the function of y to dy and the function of x to dx, like that. So if you are to do that, then you are going to have your equation written again, which is dy over dx is equal to 1 plus y over 2 plus x. That means for you to get the dx, you are going to multiply this side by dx, this side also by dx. That means this and that will go, and our dy is going to be 1 plus y over 2 plus x, then dx this side. So from there, what you're going to do is again to remove this part which is for y from the function of dx. How can we remove it? We are going to multiply this side of the equation by 1 over 1 plus y, this side also by 1 over 1 plus y, so that this 1 plus y and 1 plus y will go. You remain with 1 over 1 plus y dy is equal to, on top there you have a 1 remaining, over 2 plus x, and then dx. So after separating the variables, that's when you can integrate. So you need to integrate this side, you also integrate this side. Integrating this side of the equation, 1 over 1 plus y is going to be natural log of 1 plus y, and then is equal to integrating 1 over 2 plus x is natural log of 2 plus x, and then you say plus c. So this becomes your final answer if you are to solve this type of differential equation. All right, now we need to proceed. So by proceeding, I'll just give you some tasks that you're supposed to do, and then thereafter you need to send the answers. Feel free to inbox me your answers either on my WhatsApp or maybe just inbox or just send your answers in the comment section. I'll be able to see if what you've done is right or not. Alright, please don't forget to subscribe on my channel for more videos so that whenever I post videos, you are notified that I have posted videos and they are there to help you and also to help in your academic journey. See you next time.